Welcome back to Clinical Lab 256. And today, we're not the students, we are the detectives. Most people think that heavy task always comes from a doctor. But when it comes to glucose level, they come to us for the truth. But what is truth if the equipment is lying to you?
Come on, Ifin. It's a chemistry presentation.
Just the presentation, Dania, if we aren't accurate and precise, we could tell a healthy person they are critically ill and a sick person they are actually fine. We are the one giving the facts. And we can be just mostly right.
Look, it's simple. People think accuracy and precision is the same, but it's totally different.
Think a bit of my attempts of baking. I ended up with a burnt omelet. So, let's break it down.
Attempt. Accuracy is how close a measurement, calculation, or attempt is to the true, correct, or intended target. If you are trying to hit a bullseye, an accurate shot is one that lands right in the center. If you are weighing a 10 kg weight, an accurate scale will read exactly 10 kg. Accuracy can be understood as hitting the center on a target, like an arrow striking a bullseye, being close to the true value in measurement, such as a thermometer reading exactly 100 Celsius in boiling water, and being correct in everyday tasks, like typing your password correctly on the first try.
Precision is all about consistency. It measures how close your attempts are to each other, even if you miss the actual target. For example, if a scale reads exactly 9.5 kilograms every single time you weigh a 10 kilogram weight, it is precise, even though it is incorrect. Precision can be understood as having a tight grouping on the target, like arrows hitting the same spot on an outer ring. Giving consistent measurements such as a thermometer, reading exactly 98.2 Celsius every time it is placed in a boiling water. And being consistent in everyday life, like waking up at exactly 6:01 AM every morning.
So, let's see the professional failure.
Okay, let's see how professionals play this game. I will make sure I hit the bullseye target. Look, I'm consistent. Okay, let's see how professionals play this game. I will make sure I hit the bullseye target. Look, I'm consistent. I hit the ball at the same place 3 times. I'm so pro.
No, you're precise, but inaccurate. That is systematic error. Your machine is calibrated wrong. You're telling every patient they have high cholesterol when they're actually fine. What is systematic error? Systematic error isn't a random mistake or a fluke. It is a consistent predictable bias in one direction. If your data is always too high or always too low, that's systematic error. The scale reads 2.25 gram even after the apple is removed from the weighing scale. Then, what is the connection with Danish straw? Let's replay it. Look at Danish straws. He is incredibly consistent. He hits the exact same wrong spot 3 times in a row. His variation isn't random. If Danish was a laboratory machine, it means his aim is permanently shifted to the right. Every single result he gives will be wrong by the exact same amount.
Hey, I hit the middle. So, I'm embarrassed. I'm a genius.
That's random error. Your accurate is average, but the precision is trash. You can trust a lot that guesses only 32% of the time.
What exactly is a random error? Random error is not a consistent bias or a calibration issue. It is an unpredictable, scheduled variation in all directions. If your data fluctuate widely, sometimes too high and sometimes too low by pure chance, that's a random error. The scale reads random weight that come from unpredictable variation like wine. Let's replay Dania's throw. Random random error is pure chaos. It is caused by unpredictable variation that you cannot easily control, like a sudden change in room temperature, a shaky hand, or a minor distraction. Why does this matter in a clinical lab? So, let's look at the iron test for anemia. So, the true value for this test is 50 millimole per liter.
If our lab is precise but inaccurate, you might get this result: 5.0, 5.1, and 5.2.
The doctor said 5.0 and think their patient is dangerously enemy. This type basically treatment for a problem that doesn't exist.
If we are accurate but not precise, we will get 5, 50, and 25.
The average is 50. But the individual results are all over the place. Doctor has no idea what's actually happening.
To check excellent result, we need both of them. So we're using reference material to stay accurate and quality control to stay precise.
Because in the lab, close enough is just a fancy way of saying try again.
And that's not good. So you have to stay sharp.